Hello everyone, we will solve this today's LeetCode problem. This is add one row to tree. So here we have given the root of a binary tree and two integers value and depth. We need to add a row of nodes with a value val at the given depth. Note that the root is at depth 1 and okay, so we need to add a row with value which is given at the given depth. So the it is given that the root is at node depth 1, so we need to start from 1 not 0. So for the adding rule is what? So we have given the integer depth for each not a null tree node current at the depth minus 1. Create two tree node with value val and current left subtree root and right subtree root. Current original left tree root as a left subtree and current original subtree as a right subtree. Okay. And if the depth 1 is 1, then we need to make it as a root 1. So if you see here, we have given depth is equals to 2 and value is equals to 1. It means that at depth 2, I need to make all the left tree and the right tree as 1 and and make a child and make the existing left subtree as as its left subtree and its right subtree as a right subtree, right? If you see like this. Okay. So how to think in this? So if you see here, this is given 42416, right? So this is if I can just copy this, let's see. Mm, no, I will not able to copy. Okay. So if you see here, this is given the right subtree and the left subtree. So for that, what I can do, I will move to its level part, means its depth at the level which is given at its depth. And what I can do is I will make new tree node which is with the value given and make it as left part of that its parent element and right part as a parent element, and the existing left tree should be the new tree, the new tree node left tree and the right subtree node. So how will you move in levels? So for moving in level, if you think what data structure we use for moving in level, if you have solved level order traversal, what we use queue data structure for BFS part, right? So we use queue data structure for moving in levels. So here it is given 1, here it is given okay, let's take this is second example, this is 2, this is again 3, this is 3, right? And this is given as 1, right? So if you see here, in this case, what we'll do, we will use a queue data structure for the level order traversal. In that queue, depth is given 1 3 here, and this value is 1 and depth is 3 given. So what this depth 3 means? 1 2 this 3. It means instead of 3 1, I will insert here this. I will insert here what? I will insert okay, let's make it here. Instead of this 3 1, I will insert here 1 and it will be 3, right? It will be 3 and its right left value will be 3 and right value will be 1, right? So here it is as goes follow, right? If you see, the same is the answer here. So how will I achieve? I will move to its depth part 1, again 2. Now when my depth equals to the current level, what I will do, I will I will take a left node, which will be the current node. Okay, I need to take, I will just need a temp node, which store my this current left, which will be 2 is left part, right? This will be the 2 node left. Let's suppose this 3 is at node is at 3, so this will be, I will just traverse in this queue and move it to this till this depth which is given, and I will make the make the parent value, which is here is 3, here is 2, sorry, this will be 2, and make store this node left value, right? And I will make a new left node. I will make a new left node, which will which will be my new tree node with value 1, which will be my new tree node with value this given. And I will simply point this left part, this 2s left, to this new left node, and this new left node left will be this temp value, which is 3. In this case, this temp is 3 here, right? This temp is 3, temp value is 3. So this is how this 2 points to this one, and this 1 points to now 3. And the same case for right part, the same case for right part. What will I do? I will simply do this the right, and this is the right, and this is right. So just I will go till its parent value, and the depth is equals to the value. I will mark left point the left part to new value, and the existing left point to the left of new value, right? This just is the code, right? So we will move just till its depth, and I will simply insert new characters in this at that level, right? So if you see, we in this case we need to either it is exist left or right. I will add all the one node. So how will I do this? I will take a cube data structure for BFS traversal. So whenever you see that we need to move in level order, we will always use pure data structure here, right? So first I will check if depth is 1. If depth is 1, it means the root part should be the new value will be root part. Here it is given that depth is equals to 1. There is no depth minus 1. Create a tree node with value as the new root of the whole original tree, and the original tree is the new root left subtree, right? So what will I do? I will make a new node, and that will be with my current value which is given, and I will just point this to left and return this new node from here. If my depth is at 1, right? Right. So this will for creating root, right? If depth is not equals to 1, I will push this root part here, and also I need to take a level 1, because I need to see which where when level is equals to depth, and I will start iterating in queue. Okay, now I will check the size of queue, right? I will check the size of queue, and I will iterate in this size, or take this. Why? Suppose we are at level 4, the this size denotes the number of nodes at current level. So at suppose this is depth so at level 1 in this example, the number of nodes is 4. Now at level 2 the number of nodes is 1. Sorry, the number of nodes is 1. Number of nodes is 1. Same for this row. At level 3 that will be 2. So the number of nodes at level 3 is 2. So that's why I am iterating in this fashion, right? So this, what will be the node which is equals to q dot front, and we will pop this out. Now I will check that. Okay, I also need to increment my level value so that I can check whether this is level or not. So this level, if this level is equals to depth, it means I am at a parent of this, uh, where I have need to insert this nodes. I'm at parent of this, so this node value. So what I will do, I will just use this. I will just use this. I will just use this. This is auto time value, and this part. If this is level depth, I will simply move to this value and mark this area, right? What I have done, I have done this temp. I have declared. I have no make this node left saved at a temp, and make a new lift node here, and make a new node and assign it to its node to left, and again assign its node left to temp value, right? And same I will do for right part. Same I will do for right part. I will store node right value in temp. Now I will make new right node. New right node, and I will assign this new node right to new right node value, and again this node right left should be at temp, right? So if you don't want to, if we can also do that, do like this, that if you don't want to use an extra, then you can simply use like this, that its node left to left value is temp. So this is also correct, and this thing is also correct. If you don't want to use this, then this is also correct and this is also correct, right? This, if you don't want to use this, then this is also correct. Node right to right value, because we have already assigned node right to new right node, and its right to right is temp. uh, okay, sorry, I need to take this, because how will I store them? Okay, so this, we can use this like this. Okay, we can't we can remove this value. We can directly write like this, right? We can remove this. We can directly write this node right to right. And what will I do? I will simply move to here, and if I check again, if level is equals to depth, it means I have already inserted all the values, and I will break this loop, and I will return this root part here, right? Because if level is equals to depth, it means I have already inserted characters in all the size. So I will just move out of this loop, and I think this should goes well. Let's see. Node right. Okay, let's run again. Okay, this should be node. I missed something here. This will be 426,133. It is same. We have not inserted. Node left is new tree node. New left node is to left node. If level is equals to depth, mm this q dot size is level 1. So this size should be minus and this level should be depth. If this node is at left, then I will assign this again and this should be break. This should work fine, I think. Why it is not working? We have pushed this root value. We have pushed this root value. This q dot front is node level plus depth. Node left is that. Break it. I think I have done this correctly. Hmm. See what I have done. Oh, okay. I have not. Okay. Right. So I also need to uh, check for this. Like I have not inserted if the depth is not if there is no left if there is a depth left, then I need to insert q dot push because I am iterating in this. I have not inserted left value, right? This should be at right and this should be right. I just need to push if the level depth is not here, right? So yeah, and I will break this. I think that will be fine. Let's run. I will break after this level depth because I don't need anything after that. Okay. If I break this, then some nodes will get left. Otherwise, it will not. Okay. Yeah. Let's submit it. We have passed all the cases. The time complexity will be O of n because I need to iterate. In worst case, I need to iterate in whole of nodes, and the space complexity will be again O of the maximum number of nodes in a particular level. So yeah, thank you.